Now in this lecture video we're going to make an assessment of the power of the test that we've been looking at by comparing it with the power of the t-test. So in this section our purpose is to get a sense of the power of this nonparametric test about a population median. So to get such a sense, we will proceed by comparing the results obtained by this test with those obtained by a t-test for a population mean. Now recall that back in examples 2.1 through 2.3, we were told specifically that the data came from a normal distribution. Because the normal distribution is symmetric, the population mean and the population median are the same, and hence a hypothesis test about one is a test about the other. Hence we can translate the tests about population medians in those examples into the corresponding tests about the population mean and then use a t-test to perform those tests. When a population is symmetric about its mean, and therefore about its median as well, then tests about that parameter can be performed using either the parametric t-test or this nonparametric test about the median that we've been looking at. Now, which would be preferable? As long as both tests are appropriate from the standpoint of assumptions being met, then the procedure possessing the greatest power would be the most preferable. Hence, it is in this particular context that we are making this comparison. Obviously, if in a given situation the t-test would not be appropriate because of a violation of assumptions or something like that, then this kind of a comparison is meaningless and a nonparametric test would be preferable. So we're going to look at a series of examples, each taking looks back at examples 2.1 through 2.3. We'll start off with example 2.8. And so this is a comparison of power from the nonparametric test that we looked at to that of a t-test for the data from example 2.1. So back in that example, we were interested in testing the hypothesis that the median of the population was less than or equal to 100 against the alternative that the median was greater than 100. And since that data came from a normal distribution, we can reframe that set of hypotheses into hypotheses involving the population mean. So the null hypothesis would be that the population mean is no more than 100 against the alternative that the population mean is greater than 100. Using that data, the t-test was performed using a TI calculator, and the results are given on this next slide. We look up here in the top right panel. This is the wizard that the TI-84 calculator presents to allow you to input information about the data. And so I had the summary statistics for the data, and so I input those values. You see the mean here, the sample standard deviation, the sample size. You also enter information about the hypothesized value of the population mean, and then you down here select what the alternative hypothesis is. And so then based on that information, we've got the results of the test here in the leftmost panel. And we see here that the p-value for the test is 0.0022. So if we look back to the results that we got from the nonparametric test involving the median, the p-value for that test was 0.0176. And again, the p-value for the t-test is 0.00222. If we compare these two p-values via their ratio, 0.0176 divided by 0.00222, we see that the p-value of the nonparametric test is almost 8 times larger than the p-value for the t-test. And so the t-test in this particular situation is much more powerful than the nonparametric test for the median. In fact, if we were using a 0.01 level of significance, we see that we would not reject the null hypothesis if we were using the nonparametric test, but we would reject the null hypothesis if we had been using the t-test. All right, in example 9, we're going to do the same kind of thing, but using the data from example 2.2. In that example, we were looking to see whether there was sufficient evidence to conclude that the median of the population is less than 75. And so again, because the data come from a normal distribution, we're told that in the statement of the problem, that we can reframe the entire problem in terms of the normal distribution and in terms of the population mean. So these are the hypotheses that we'll be testing. And again, we perform the test on the TI-84 calculator, inputting the appropriate information into the wizard, and then getting these results that we see here. And so we see that the p-value associated with this t-test is 0.0158. going back to example 2.2 where we did the nonparametric test, the p-value for that analysis was 0.11894. So we compare that to the p-value of the t-test, and we again see that the p-value for the nonparametric test is between 7 and 8 times larger than the p-value for the t-test. And so again, the t-test is much more powerful in this particular situation than is the nonparametric test. And we can see here that this makes a big difference. Not only would we draw different conclusions at the 0.05 level of significance, but we would even draw different conclusions at the 0.1 level of significance. At the 0.1 level, we would fail to reject the null hypothesis if we had been using the nonparametric test. If we were using the t-test, we would reject not only at the 0.1 level, but also at the 0.05 level, and even at the 0.02 level. So we see that these are very important issues to consider because they can have a big impact on your decision making. All right, then the final example, example 2.10. This is reanalyzing the data from 2.3 using a t-test. In that example 2.3, the problem of interest was to see whether there was sufficient evidence to conclude that the median of the population was different than 0. And so, again, because the data come from a normal distribution, and that distribution is symmetric, the mean and the median coincide. And so we can reformulate those hypotheses in terms of the population mean and then do a t-test. And so here are the results of that test. First, here on the upper right, you see the instructions I'm using to perform the analysis. In the bottom right, we haven't really talked about these, but this is kind of nice. On the TI-84 calculator, you can have it produce this kind of a graphic which shows you visually, graphically, what the test is doing. And so we see this is a two-tailed test. And the total area, this is calculating the p-value. The total area of the shaded regions here is the p-value, which is 0.032. If we go back to example 2.3, we see that in this case, the nonparametric test did actually a little bit better in terms of its p-value being fairly small. So the p-value of the nonparametric test was just a little bit smaller than the p-value for the t-test, right? So that's actually kind of surprising because, well, we'll talk about this in a little bit. But in this case, the two tests are comparable, it appears, in terms of power. So putting all this information together, obviously these examples are not proofs of anything, but they do suggest that the nonparametric test about the population median that we've been looking at is less powerful and perhaps a lot less powerful than the corresponding parametric t-test, at least in certain situations. And that is indeed the case. It turns out that in many, many situations, this nonparametric test is less powerful than the corresponding t-test. And again, we're wanting to make meaningful comparisons here. So we're talking about when both tests are appropriate. And because of the fact that the nonparametric test tends to be less powerful, that's why, and if I go back to the previous slide, that's why it's a little bit surprising that the nonparametric test p-value is actually a little bit smaller than the t-test p-value. Because you'll see as you get more experienced with this, as you analyze data, and if you look at situations where both the parametric t-test and the nonparametric median test are appropriate, can both be used, you'll usually see that the t-test p-value is quite a bit smaller. Now, this loss of power is not surprising, and it's actually to be expected. The t-test is appropriate for data that are either at the interval or the ratio level. Data from a normal distribution is certainly at both of those levels. On the other hand, recall that in performing the nonparametric test, the original data values, the y's, which were at the interval or ratio level because they're coming from a continuous distribution, and so those distributions tend to be at the interval or ratio level. All right, so we started off with our y variables coming from a continuous distribution, and the data are at the interval or ratio level. But then we transformed those response variables or random variables into 0, 1 indicator variables. We dichotomized them based on whether a given y value was greater than the hypothesized value of the population median. So we transform those interval or ratio level data values into indicator variables that are at the nominal level. Now remember, there are 4 levels of data. The nominal level, that's the lowest level of data. There's really the least amount of information possible in a nominal level variable. And you've got the ordinal level. and you've got the interval level and then the ratio level. So in order to transform the data so that we can perform this nonparametric test, we take it all the way from an interval or ratio level variable down to a nominal level. And in transforming a variable from the interval or ratio level to the nominal level, there's a loss of a great deal of information. All right, so there are two important ramifications of this transformation and the corresponding loss of information. Two ramifications. Number one, we get a procedure that is more broadly applicable, as we've discussed and seen. Remember, we said that we can apply this procedure about testing hypotheses about population medians. We can apply this in all sorts of situations when a t-test would not be appropriate. For example, when the data are highly skewed or when they've got heavy tails. So we've transformed the data and come up with a procedure that is much more broadly applicable. But there's also a loss of power in making inferences about the measure of location, the mean or the median, precisely because certain aspects of the data have been destroyed in that transformation process. So those are the two really important ramifications to keep in mind. When we do that transformation, we get a procedure that is more broadly applicable. Now, why is that? Because we have trimmed away or destroyed certain aspects of the data that were problematic, either in terms of shape or heaviness of tails or things like that. But by getting rid of that information, in those situations where that type of information would not have been problematic, so for example, if the data is normally distributed, or at least very close to being normally distributed, by getting rid of that information, we're still getting rid of a lot of information. That is what degrades the power of that nonparametric test. So the sacrifice of certain aspects of the data in order to come up with a nonparametric procedure that is more broadly applicable comes at a price. And this price is a loss of power, which is meaningful at least in those situations where both a t-test and the nonparametric test are applicable. So what should one do as a matter of practice? Well, when the t-test is appropriate, use it. Now when it's not appropriate, consider using a nonparametric alternative, realizing that there may be a significant decrease in power from what one may be accustomed to having. Now, with these things in mind, and in particular, the intuitive explanation as to why this nonparametric test has lower power than the t-test, perhaps we can think of ways to come up with an alternative nonparametric test that does not suffer such a degradation in power. So we'll be looking at some additional nonparametric tests, and those nonparametric tests will tend to have more power, sometimes a lot more power, than this particular nonparametric test about the population median. In fact, some of these other procedures may have power that rival that of the t-test. And so that's something to think about. How might you come up with a test to do that? We will be looking at that in the very near future. But that's the end of this lecture video. We will continue on in the next video.